Recall that I to the first power is the square root of negative 1, which is I. I squared is negative 1. And I to the third would then be negative 1 times another I, which is negative I. And I to the fourth would be take what you have, negative I times another I, which is negative I squared, which is negative of negative 1, which is positive 1. I to the fifth, take what you have times another I, which is I. I to the sixth, take what you have times another I squared, which is negative 1. I to the seventh, take that negative 1 times another I, which is negative I. Have you noticed any pattern here? We went from I to negative 1 to negative I to 1, back to I, negative 1, negative I, and it would be back to 1, and then I, negative 1, negative I, back to 1. So this pattern repeats every 4 times, right? There's a pattern of 4. And I to the 0th power, well, anything to the 0th power is 1, so that will also be part of this pattern as well. So since the power repeats every 4 times, a way that we can find the equivalent power of I is by just dividing the exponent by 4 and seeing what the remainder is. So example, the I to the 7, that's an easy one to check. If I do 7 divided by 4, that goes in 1 time, and the remainder is 3. So that's equivalent to I to the third, which is negative I. So this allows us to find the exponential expression easier by reducing that exponent. Say the exponent is 85, right? That will be hard to figure out. So if we find the equivalent value using the remainder from a division by 4, then that will allow us to find those higher exponents faster. Let's find some powers of I. For example, I to the 11. So we figure out how many times 4 goes into 11, and that's going to be twice, which is 8. So the remainder is 3. So I to the 11th is equivalent to I to the third, which is negative I. If we just remember that pattern, right? 1, I, negative 1, negative I. That's a remainder of 0, 1, 2, and 3. For example, I to the 40. How many times does 4 go into 40? And that's going to be 10 times with a remainder of 0. So I to the 40 is equivalent to I to the 0, which is 1. For C, I to the 50th power. So how many times does 4 go into 50? And that's going to be 12 times with a remainder of 2. So I to the 50 is equivalent to I squared, which is negative 1. For D, I to the negative 10, we can't apply this rule because the exponent is negative. So the first thing that we need to do is make sure we change this. We move the base so that I has a positive exponent. Now I can look for how many times 4 goes into the exponent of 10, which is twice with a remainder of 2. So that means that I to the 10th is equivalent to I squared, which is negative 1. And 1 divided by negative 1 is negative 1. So that will be the exponential expression in a simplified form.